Okay, everybody, let's talk about divisibility rules and prime factorizations. So first, let's get some terminology. A prime number is a natural number that has exactly two divisors, one in itself. Natural numbers are 1, 2, 3, 4, 5, dot, dot, dot. Okay, so a prime number has exactly two divisors, one in itself, like 2, like 3, 5. A composite number has more than two divisors, okay, like 4. It's divisible by 4, 1, and 2. 6 is not only divisible by just 6 and 1, but also 2 and 3. So more than two divisors. Now notice what that means. 1 is neither prime nor composite because it only has one divisor. 1 divided by 1, 1 divided by 1. Okay, so that's confusing for people sometimes, or just mistaken, easy to be mistaken. 1 is neither prime nor composite. Okay, just because it's odd doesn't mean it's prime, like 9 is divisible by 3 in addition to 1 and 9. Okay, this vertical bar, it stands for divides, and if we put a slash through it, it means does not divide. So don't confuse the completely vertical bar with the slash. This expression, 3 divides 6, is merely stating 3 divides 6. There's no operation to perform. It's not a fraction. It doesn't look like this with the slash, where this is 3/6, which is a fraction that'll reduce 1/2, right? So this is 3 divides into 6. This is 3 divided by 6. Okay, likewise, if I put the vertical bar with a slash through it, this is just saying 4 is not a divisor or a factor. Those are the same words, divisor or a factor of 6. 4 does not divide into 6. Okay, but once again, just for reiteration, if I wrote it like this with a slashed bar, oh, that's a fraction, that's an operation, and we can simplify that to the fraction 2/3. Okay, so we have some rules of divisibility that can help us determine if a number has a particular divisor or factors. Okay, and so here we are. Notice we don't really have one for 7, okay, or 11. There really is one for 11, but we're not going to talk about it in here. Okay, so let's take a number. $14,288. And I want to know, is it divisible by 2? For a number to be divisible by 2, okay, all we need to know is if the last digit is divisible by 2, then the entire number is. And yes, 8 is divisible by 2, so 14,288 is. Okay, to see if a number is divisible by 3, the sum, which means add the digits. So 1 plus 4 plus 2 plus 8 plus 8. Okay, 1 plus 4 is 5. 7 plus 8 is 15 plus 8 is 23. Okay, so is 23 divisible by 3? Hey, if we didn't know, I hope we do, but suppose we get a number where I don't know, add those digits. Is 5 divisible by 3? No, that means this entire number is not divisible by 3. Okay, and when we have large numbers, this is way easier math to do than actually dividing it and seeing if it's divisible by 3 or not. Okay, to tell if a number is divisible by 4, the last 2 digits have to be divisible by 4. So now I would look at not just 8, but 88. Is 88 divisible by 4? Yes. Now, if I didn't know, I would have to go over here and actually physically divide it and see if it is. Okay, to tell if a number is divisible by 5, The last digit is either a 0 or a 5. So I look up here at the last digit. Well, it's not 0, it's not 5. This number is not divisible by 5. To tell if a number is divisible by 6, it's got to be divisible by both 2 and 3. So 2, and 3, this one's not divisible by both 2 and 3, so it's not divisible by 6. Okay, 8, we look at the last 3 digits. Okay, so all 3 of these. Is 288 divisible by 8? I don't know. So let's divide it. But at least I just get to divide a 3-digit number instead of a 5 or 6 or 7-digit number. 8 goes into 28 3 times. 3 times 8 is 24. And 8 goes into 48 6 times. Yes, this number is divisible by 8. Is it divisible by 9? Well, the question is the sum of the digits again. And we already did that once. So the sum of the digits is 23 or 5 if we continue. And so, no, 9 does not divide into 5, so it's not divisible by 9. To be divisible by 10, the last digit's got to be a 0. The last digit is not a 0. And to be divisible by 12, it's got to be divisible by both 3 and 4. So it's not divisible by 3, but it is 4. So since it's not divisible by both of them, it's not divisible by 12. Okay, so those are our rules for divisibility that we need to learn. So one more thing. Let's find the prime factorization of a number. Okay, so let's start with a number like 700. Now the prime factorization means we're going to write the number as a product of primes only. Remember what it meant to be a prime, and product means multiply. So I'm going to write a number where it's only prime numbers being multiplied. Okay, so if I take the number 700, I think of any two numbers that multiply to give 700. So some of you might have said 70 times 10, some might have said 7 times 100, whichever way. I thought of 7 times 100. Okay, 70 times 10 would have been okay with the first two numbers you think of. And anytime you get one of those numbers that's prime, you circle it, and that branch stops. Then you keep going with the other numbers. So 100, what about 10 times 10? You could put 50 times 2, you could put 25 times 4, whatever you think of, everybody in the end will get the same answer. Now, neither of these are prime, so I keep going. So 5 times 2 and 5 times 2. And notice every one of those is a prime number. So once everyone is prime and I don't have any branches continuing, here's my prime factorization. So I'm going to find my smallest number of the primes and go up to my biggest number. And then I'm going to put as an exponent how many there are, because there are 2 2s, and because it's a product, we're multiplying, right? And there are 2 5s. So if we multiply that back out, we're going to get 700. Prime factorization is going to be an important tool for us. We're going to use it a lot for various things all throughout math. Okay, so I really need to know how to do that. So let's do another one. 320. Yeah, and anytime a number ends in 0 or multiple zeros, it should be fairly easy to come up with two numbers. Like this one I see. What about 32 times 10? Okay, as long as neither one is prime, I keep going. So maybe 32, 4 times 8, 16 times 2, whatever you want to do, but don't do 4 times 16, which is what I was about to put since we were talking. And 10 is 2 times 5, or 5 times 2. And notice that's the only ones you can come up with for 10. That's another clue that, hey, those are prime numbers, and I'm finished with that. Okay, 4 is 2 times 2, the only way I can get 4. And 8 is 4 times 2. So I see some prime numbers there. But I still have a number that I'm not finished with. So 2 times 2 again. Okay, now that everything is circled as a prime number, I'm going to write, all I have are 2's and 5's. So 2 is the smallest number. I'm going to put it first. And I have a bunch of 2's though. 1, 2, 3, 4, 5, 6. That's what my exponent tells me, how many 2's are being multiplied together. And there's my prime factorization for 320. Okay, so divisibility rules and prime factorizations. Let me know if you need anything with that.